Shivam, have you arrived? forward and take the seats in the front row. That Kindly keep your cell phones on the silent mode. We'll begin shortly. Students, I request you to kindly come forward and occupy the seats in the front rows. Kindly switch off your mobile phones or put them on the silent mode. We'll begin shortly. Shiva, tell me to maintain decorum in the hall.
Yeah, once let them settle. Let them settle एक बार बैठ जाओ फिर आइए. Everyone please maintain decorum in the auditorium. Kindly put your mobile phones in silent mode or switch it off.
Students are requested to please come forward and maintain decorum in the hall.
Students, you're requested to please maintain decorum in the auditorium. Kindly switch off your mobile phones or put them in silent mode. Thank you. Students, we request you all to please maintain decorum. Kindly put your mobile phones in silent mode. We'll begin shortly.
Good morning, everyone. Esteemed session speakers, Dr. Shagnik De and Dr. Arup Kumar Mitro, respected session chair Professor Shuchorita Roy, faculty members, invited guests, conference participants and fellow students. I welcome you all to the second day of the International Conference for Climate Change Global Cooperation, organized by St. Xavier's College, Autonomous, Kolkata. After yesterday's enriching session, we hope today will be equally illuminating with knowledge and innovation. We look forward to hearing from our speakers on matters of utmost importance and urgent action. We, Kahini Majumdar and Shivam Bajaj, are the hosts for this session.
Protection of our environment is not a luxury that we can enjoy, but a simple matter of survival. Let us commence the session with these inspiring words of encouragement that stimulate us to step up and do our part in conserving and rebuilding the environment for the generations to come. We request the session chair, Professor Sucharita Roy, and our esteemed speaker, Dr. Shagnik De, to come to the dais and take their seats. Thank you. Professor Sucharita Roy is the head of Department of Mathematics at St. Xavier's College, Kolkata. She completed her MSc in Applied Mathematics from University of Calcutta. Her area of specialization is Advanced Mathematical Ecology. She is currently pursuing research in stochastic processes and Bayesian statistics. She has a teaching experience of more than 13 years. She earlier worked as a full-time permanent faculty in Mathematics and Statistics Department for 2 years in J.D. Birla College and also in Bithune College. We would now like to felicitate the chairperson with a token of appreciation. Thank you. Professor Roy, we request you to please introduce our esteemed speaker.
A very good morning to all. I welcome you all to the second day of this International Conference on Global Climate Change, Global Cooperation. I deem it a great honor and privilege to introduce the eminent speaker for today's first technical session, Dr. Shagnik De. Professor De is Institute Chair Professor at the Center for Atmospheric Sciences, IIT Delhi. He received his MSc in Applied Geoscience from Jadavpur University, Kolkata, and MTech and PhD from Indian Institute of Technology, Kanpur, India. He worked 3 years, August 2007 to July 2010, as postdoctoral scientist at Department of Atmospheric Sciences, University of Illinois at Urbana-Champaign, USA. He joined the Center for Atmospheric Sciences, IIT Delhi, as assistant professor in 2010, as an associate professor in 2016, and as a professor in 2022. His research interests are to understand air quality, climate change, and health nexus, and remote sensing of the Earth's climate system. He has published more than 120 peer-reviewed research articles with H index 39 as per Scopus and 42 as per Google Scholar. He received the INSC Young Scientist Medal in the year 2008, NASI Scopus Young Scientist Award in 2012, Dr. Sudhanshu Kumar Banerjee MOES Outstanding Young Faculty Fellowship for the period 2011-2013, and Teaching Excellence Award from IIT Delhi in 2016. He is an international collaborator and science team member of NASA's upcoming MAIA satellite mission and served as an expert member of WHO Global Platform on Air Quality and Health. He is a collaborator of the Global Burden of Disease Study and Local Burden of Disease Study. Dr. De has been awarded the Fulbright Nehru Academic and Professional Excellence Fellowship for 2017-18. Dr. De is the coordinator of Center of Excellence for Research on Transportation on Clean Air, CERCA, IIT Delhi, and is an associate faculty of School of Public Policy and Transportation Research and Injury Prevention Center at IIT Delhi. He was appointed as the Institute Chair Professor with effect from July 2019. He is also a member of WHO Southeast Asia Non-Communicable Diseases Regional Technical Advisory Group. He is serving as Associate Editor of Atmospheric Environment, Elsevier Journal, and is also the editorial board member of Scientific Reports, Nature, and Earth System Dynamics, that is EGU. Dr. De's latest research group news includes new article on a comparative assessment of near global distributions of individual cloud types from space-borne active and passive remote sensing and ground observations in International Journal of Climatology. Also a perspective on the impact of air pollution on child health in India, which is accepted in Indian Pediatrics Journal. Today, we are fortunate enough to have him with us, and today Dr. De will speak on the topic, what does India need to develop a climate-resilient health infrastructure? So without further ado, I hand it over to you, sir. Thank you.
Ma'am, before that, Professor, please, can you felicitate our esteemed speaker?
Yeah, sure.
Yeah, good morning, everyone. Thank you, Professor Roy, for the kind introduction. It's a great pleasure to be here and talking to you about this very important aspect of climate change, particularly for the students, because I'm sure yesterday you must have heard from other distinguished speakers about various aspects of climate change, science, impacts, adaptation, mitigation, and issues like that. When you talk about climate impacts, climate change is impacting all spheres of our life. Whatever we are doing today is definitely going to be impacted by climate change. Unfortunately, health is one issue which has not been really explored when we talk about the climate change impacts in that way. The reason is that when you talk about health, it's a purely interdisciplinary topic. So it's not a domain of environmental science or atmospheric science. It's not also purely domain of medical science as we expect it. So today I'm going to talk about what I think India should do to develop a climate resilient health infrastructure. Let me start with the demographic profiles of India. Because again, when you talk about health, let us first understand what is the condition today. So if you see the top panel here, this is what the population projection. So we are currently around at 1.4 billion population. And the population is projected to rise to almost 1.7 billion by 2055-60. And after that, the population will start declining in India. And this is very interesting because we think that the population will continue rising. One of the main reasons of this declining is that we have already hit the fertility threshold. Health Ministry last year has released this survey called National Family Health Survey, where for the first time the national fertility rate has been estimated at 2.1, which is just the threshold for the replacement. That means if it is lower than 2.1, so in near future what will happen is that the population will start declining. And obviously the other strong reason of this projected decline in the population is that overall resource is going to decline. Now, why population is important? Because when you talk about the health impacts, ultimately it is the demography for which we care. So total population is important. At the same time, the age of the population itself is also very important because the health risk is very different as a function of age. So the bottom panel here shows that what is the age distribution for male and female. So the blue curve is for 2019, the latest number if you see, and 2100 is the projections. So what you notice here is that both for male and female, India is at an advantageous position because we see that most of the population in India now is in that so-called young category. So India has a very large working force and you are all the next generation that will contribute to the growing economy of India. However, that's going to shift. So as time will pass, you will see that the curve will shift more upward, the orange one in the bottom panel, which means that there will be larger fraction of aged people, and it means that if nothing changes, simply because people are aging, it means that the health burden of any environmental factor will also keep increasing. And on top of that, we'll see actually, how things are expected to change. Life expectancy, if you see, again, it's very interesting because today, at birth, life expectancy of a female is around 72 years, and for male is 69 years. So it means that when a child is born, if it's female, the child is expected to live at least till 72 years. So when we try to understand the impact on health, and particularly what will be the impact on mortality, we mean mostly premature death. And if you see how the life expectancy is projected, obviously because the overall health infrastructure is improving, medical science is improving in a big way, people are living longer. So in India, life expectancy is projected to increase. However, it does not mean that people will live healthily. And this is very important, because when we talk about the environmental impact on health, even if a person is alive, just imagine somebody is having asthma. So if that person lives longer, it means that the person will live longer but with that morbidity burden. So the person perhaps will suffer more. And in health epidemiology, we actually try to quantify this. And the fertility rate I already mentioned earlier, and you can see that how the fertility rate is coming down and is actually projected to do so. This is very interesting. Again, if you see the healthcare spending today, now on an average, every Indian annually spend around $69, out of which the green one is out-of-pocket spending. So it means that today in India, our healthcare system is like that. Mostly we spend from our own pocket. There is very, very less contribution from government, which is the light blue color, and very few people actually have medical insurance. So out of this total $69, you see that $7 is covered from medical insurance. So mostly it's out-of-pocket expenditure. And what is projected for 2050, you see that first of all this 69 number will go tremendously, 244, and it means that healthcare expenditure of a family or an individual is definitely going to increase. And any additional factor that is impacting health is definitely going to pull up that number. So it's really worrisome unless we make a major change in our overall medical system, giving more universal medical coverage and all. I think the situation is really worrisome. Okay, now let me show you what are the top causes of the health burden today. You see that today, most people in India die from ischemic heart disease. And these all these data actually are compiled as part of the global burden of disease. If you just Google global burden of disease, India, the first link will take you actually to where all the data are kept in a very, very nice visualization way. I was just explaining this to a student before coming here. And then you have these different diseases, like ischemic heart disease is followed by chronic obstructive pulmonary disease, stroke, diarrhea, neonatal disorder, and many things. Now, out of the top 10 diseases, or rather causes of death, you can see that some of them actually are declining. For example, diarrhea, neonatal disorder. India has made tremendous progress in reducing infant and child mortality over years. Tuberculosis is going down. But what is shown as positive percentage change in the last decade are the non-communicable diseases. You see that in the last decade alone, ischemic heart disease, COPD, stroke, diabetes, these have all gone massively. Now, these are the diseases today where not just in India, but mostly the global population suffers from. And all these diseases have multiple risk factors. They are impacted by our behavior, the kind of food we are taking, the kind of lifestyle that we are living in, and in addition to that, there are environmental risk factors. Now, what is causing these diseases, if you try to now see in terms of not the top cause of death, but risk factors wise, then it's also become very interesting in India. You see now in India, the single largest health risk even today is malnutrition. Although malnutrition has significantly declined, but it still remains as the single largest health risk, followed by what? Air pollution. And then comes high blood pressure, tobacco and all. So today in India, more people are affected by air pollution than smoking or tobacco use. And obviously, other things are also there, which we expect, like high glucose, dietary risks, and various other things. So this is the picture now. Now let me show how climate change may disturb the current scenario. Now this pathways is very, very complex. And that is why in the beginning I said that we have not really fully explored these linkages. It requires interdisciplinary approach. So climate change will have a direct impact on health, mainly through increased heat stress. What is heat stress? So heat stress is nothing but the stress our body experiences when we are exposed to extreme heat. Now heat stress is certainly going to increase because the temperature definitely will increase because of the global warming. Natural disasters, the frequency will increase, intensity will increase. You all have experienced two devastating cyclones in the recent past, Amphan and I'm sure you are following the news that cyclone intensity and frequency is also going to increase. Exposure to UV radiation is another issue. So these have direct connections, and climate change will impact this. And the moment this heat stress increases, frequency of natural disasters increases, there will be an impact on health. There are indirect pathways also. What are these pathways? So these indirect pathways basically starts by changing the ecology and the environment because of the climate change. And if that happens, then vector-borne and water-borne diseases, their paradigms will shift. And it has a strong connection to water and air pollution. And there are some tertiary connections which we hardly have understood. These are malnutrition, as I showed, the single largest risk today. Now, there are some studies, not in India, but in other parts of the world, where it is shown that climate change is definitely going to worsen the condition. Mental stress is another issue, which we hardly talk about. Under the global burden of disease, we have now estimates of mental stress, and you will be surprised to know that as per the latest estimates, 1 out of 6 Indians today suffers from mental stress, be it anxiety, be it depression, be it something else, for many reasons. And there are studies again in Europe and other places where it is shown that climate change will certainly exacerbate the mental stress, and then there will be more conflicts which will also lead to our health. More conflict due to restricted research. So you can understand these are very complex pathways and there are interconnections. So I will give you very quick examples in the next 30 minutes or so to show what we know in India, and you will realize that we really know very less and need to do a lot more to have the full picture. Okay, so the title of my topic is this climate resilience health infrastructure. What do I mean by it? I meant that what we require really is integrating science, adaptation and mitigation aspect of the climate change in a seamless way, which we are not doing today. The people who are doing climate science, for example, they are predicting at what rate the cyclones will increase. They are not talking to the social scientists or the health sector, because what will happen? The moment there is an extreme rainfall because of any natural disaster, there will be flooding. And because of this flood, you can have vector-borne diseases. Now, we have a very good early warning system for cyclone or even for rainfall from our India Meteorological Department. What we now need to do is that we take that early warning system and translate it into health warning system, so that you know that if it is going to rain this much, and again you are from various parts of the Kolkata city or maybe outside in the suburbs, you have noticed that when it rains, not everywhere it becomes waterlogged. So the problem will be in the cities where there is waterlogging. So you need to then bring those local features into your health warning system. Because what the meteorological forecast does, which is the short-term forecast in the top, is simply saying that Kolkata will receive this much rainfall. Now we are not doing that last mile connectivity. And that is what we need to do really to develop a system. That means the moment I know that it's going to rain intensely, then I need to predict where there will be water stagnation and more likely chance of mosquito breeding and further down the line. So there are some attempts now to forecast dengue and malaria. But I think we have to go a long way before we come up with a city-specific name. Then on top of this short-term infrastructure or health warning that I'm talking about, you also need to work on the long-term projections. Now, from science, we already have these projections. As I showed that now we have very robust projections of how much temperature is going to change, more or less with certain accuracy, how much rainfall is going to change in the next 30, 40, 50, 60 years. What we need to do is that if this is how this climate going to change, how the health system itself will respond, whether people will get adapt to it. In fact, there is a very interesting story published a couple of days ago. You all heard about this extreme heat wave in Europe. And when I was in Europe a couple of summers ago, before COVID and all, so in Europe typically, temperature does not go up. So nobody has fan and all. And that is why people are suffering more. So the moment temperature crosses 35 degrees, just imagine living without a fan or anything. So people are not adjusted to it, but now every house is having air-conditioned fan and all, but still 38, 40 degree centigrade temperature means a heat wave in the European context, and people are dying. So this report is saying that in 30 years' time, today what is felt as heat wave will be the normal summer. Now the question is that will people be adapted to it? We don't know. So those are the things I'm talking about is required, that you try to take this science and try to see whether the society is going to adapt to it, and obviously, side by side, you keep working on the mitigation aspects. Now climate change, again, mitigation is a very, very complex thing. So at least if we know what are the vulnerable areas that are going to be affected by all these complex pathways, you map, and then you try to see what is the present health conditions and what kind of health infrastructure is really required. So this kind of future vision is very, very important. Now today every state is mandated to prepare a state air action plan, climate action plan, and health action plan. Unfortunately, I have seen that each state, you have health department, you have environmental department, and you have science department, they are building these state action plans. They are not talking to each other. So they are completely working in silos without understanding, how one plan can potentially impact others. Okay, now let me show you some interesting example, what we have learned in India. So we have now a very good data about the weather disasters. So this paper from IMD group, you can see that they have done an assessment and they have shown how weather-related events, mortality related to weather events has increased. And that is what I am mentioning, that now we have a very good weather forecasting system, we need to move to disease forecasting. The moment you try to forecast disease, biological knowledge and social knowledge is very important. This map shows the climate vulnerability, and you can see that different colors. So district-wise, it is shown that which district will be more affected by cyclone, which district will be more affected by drought, flood, and combination of these. So if you focus on West Bengal, you mostly see that either it is cyclone or flood or combination. And very interesting, in the central India as well as in Rajasthan and some other places which is shown in yellow color, you see those districts will be hit hard by flood and drought. Because our rainfall characteristics have changed so much, and I'm sure you are, again, in media these are reported, that now Rajasthan time to time gets extreme rain, and they are not used to it. So whenever it rains, it gets flooded, or it is drought. So the same district has potentially, impact from both flood and drought and all. So if you have this kind of information, then let us take this, interpret in the social context and build the health infrastructure. In fact, Health Ministry has a program now on climate change and health where they are trying to actually develop such infrastructure. UV exposure, very interesting. Not much research has happened though. Mostly research has happened in developed countries. So this is the UV scale, and very interestingly, if you see that too less UV is also harmful. We all know that too much UV leads to skin cancer and other things, but too less UV now we know is also harmful, particularly in the context of, and this has happened actually in the Scandinavian countries where it has been, so those countries have one of the highest rates of suicides. And one of the strong reason is actually mental depression, and they tracked it back to certain changes in the hormone balance because of very less radiation exposure. And these are very interesting work is done. Now in India we are okay because we live in this middle part where the risk is less. So for India, UV exposure is not an issue, but you have all heard about Antarctic ozone hole. That hole is now healing. Now the problem has shifted to Arctic, and there is a very interesting study done where it is now showing that climate change is now favoring and accelerating the Arctic ozone hole. Now Antarctic ozone hole has a huge importance from climate perspective, but from health perspective, because nobody lives in Antarctica, it was quite okay. But Arctic ozone hole has tremendous impact, will have tremendous impact because there is population in the Arctic region, Canada, Russia and all these things. Malnutrition, as I said, very, very important, and we all know that the major reason of malnutrition is not enough nutrition. So food security is a very big issue. Now the food security is going to get hit by climate change. Multiple ways. How? Obviously, CO2 level is increasing, which is actually the primary cause of global warming. Now it has been observed that when the temperature is very high, it has negative impact on the crop productivity. On top of that, the rainfall patterns are changing, the radiation is changing. And most importantly, surface ozone, which is a pollutant, it also negatively impacts the crop. So many environmental factors are changing in the wrong direction, which will most likely reduce the crop productivity. There are also studies which have shown that not only crop productivity, but the nutritional value of the crop is going to get impacted. Now, these are just the environmental factors, but think what is happening to the land use and land cover. Because the population is increasing, we are converting the natural land to urban areas to build houses and all. So in near future, there will be less land available to grow crops. And the problem does not end here. Because the population is not just growing, but because of economic reasons, people are moving from rural to urban area. And there was a very good report by World Bank which showed that it will be difficult to get people in future who will be willingly growing food. Because nobody wants to be a farmer today. So even if land is there. And how these things will pan out, very difficult. But this is a reality, and some studies have been done, not in India but elsewhere. On top of that, when we grow crops, as the heat is going to increase, that will also impact. Now, all these negative things, we are trying to deal with only one weapon, that is technology. What is this weapon? Basically, we are trying to now genetically altered crops. We are talking about climate resilient crops. But perhaps they can withstand the impact of climate change. But all the other human factors, if nobody is there to, willing to grow crops, what will we do with these genetically altered crops? Nobody knows. So again, this food insecurity problem is not we are talking about in such kind of holistic interdisciplinary manner. Some work is done in this area and saying that, for example, if you see there are many studies which have shown that ozone is going to increase in future, which will have negative impact on crop. Air pollution is going to increase. In fact, we have shown in a study done with ISI colleagues that already India, there is a loss in wheat yield because of the air pollution and climate change. I'm not going into details into the mathematics and all, but the main message is that global warming and local air pollution have significantly reduced wheat yield in India. So these informations are there, but then these other informations require social scientists, require economists, require agricultural scientists, all come on board and solve this problem. So again, I'm trying to draw this attention. Okay, vector-borne disease. Why I said that it's important? You see that, for example, if you take malaria, the two pathogens, P. falciparum and P. vivax, these pathogens survive in certain conditions. For example, P. falciparum, between 16 to 39 degree temperature, they survive. Now, and we call this transmission window. Now, what is happening is that temperature is increasing, so this transmission window is shifting. So the place where you earlier saw malaria pathogens sustaining, now, for example, Orissa is one case where a lot of malaria cases used to happen, but now Orissa became hotter and moved out of the transmission window zone. That is good. So we are getting less and less malaria in Orissa. But what is not good is that now places which was outside this domain, particularly in the colder side, Himalayan foothills and many places, now they are warm and within this transmission window. So all it is happening is that the focus has shifted. And similarly for any other pathogens, you can do this analysis. So this is a very nice work done by Dr. Dhiman and his colleagues, where you can see that in future, what is this change in transmission windows for these two pathogens of malaria? They have mapped how long or how much this transmission window is going to change. So anywhere you see blue color, the transmission window will get shortened. It means that the chance of malaria occurring in those regions is going to decrease. The regions where the transmission window is expanding, this is the potential malaria zone. And again, similar kind of research is required for other vector-borne diseases. Heat stress, as I said, is so interesting and fascinating, and because I personally work in this particular area. So the first challenge is that for Indian population, what is the best way to actually quantify the stress that our body suffers? Obviously, you understand that when we are exposed to heat, temperature is not the only thing. In fact, humidity is the other important factor. If it is humid, even if the temperature is lower, we feel uncomfortable. And there are many studies done in Europe and other places where they try to see that when a person is involved in some activity, that means we are doing some activity, it is generating metabolic heat also. How we try to adjust and how our body tries to remain in thermal equilibrium by exchanging heat. And if the outside heat condition is increasing, and if this exchange is not happening smoothly, then what will happen is our body core temperature will start increasing and reach a threshold point beyond which we will suffer heat stroke. So first what we have done is that, and again if you see the right map here, India has different climate zones. So obviously you cannot have different conditions across the climate. So what we first did, using 40 years of meteorological data, we did some statistical analysis and tried to define certain comfort levels and I'm just showing 3 examples in semi-arid, humid, subtropical, and tropical, wet and dry. What should be these comfort levels? And then we looked into some data. And first we mapped also what are the vulnerable districts based on this new India heat index that we proposed. And you can see that hot, very hot or sweltering is what we actually care, because these are the extreme conditions. So there are certain districts, obviously, which are very vulnerable in terms of numbers. 24 districts during the peak summer period is really, really under sweltering conditions and all. But we did more. We tried to also understand, and again, I will not go into details into the methodology. We tried to see actually that is there any excess risk of mortality when these conditions change. So the left panel is from 2 cities. We got data, Varanasi and Delhi. Varanasi belongs to humid subtropical climate. Delhi belongs to semi-arid climate. What we are trying to calculate here is that what is the excess mortality risk when there is a heat wave versus non-heat wave day during peak summer, and clearly you see the risk is higher because your x-axis, which is the relative risk, it is more than 1. Similarly, also for these different heat stress conditions, hot, very hot, sweltering, we tried to see what is the excess mortality risk compared to the comfortable situation. And then again, in all the 3 cities, you can see that as you move from these extreme conditions, your mortality risk is going to increase. And there are differences in male and female. So we are now trying to repeat this for many, many cities and planning to do it in a national scale. Air pollution, where again, I personally work, and these are the 2 most important pollutants for which lot of data, lot of studies are done, particularly PM 2.5, which is basically the fine particulate matter, which is smaller than 2.5 micron. And then what happens is that when we breathe, these particles go into our respiratory system and creates a lot of health hazard. So what we first did is that there are hardly any data to do any national scale analysis. We developed this database of PM 2.5 for Central Pollution Control Board, and now I am working with West Bengal Pollution Control Board, many state boards, where you can see that we are now mapping PM 2.5 over the entire country at 1 kilometer by 1 kilometer resolution. So every day we have data for the last 22 years. Now and you can see how good is our satellite-based estimates compared with ground measurements, so in this scatter plot. Now once you have such kind of data, not only from air quality management perspective, but I will show how this data we are using now for health impact assessment. So one study we did showing the impact on stunting. Now stunting is a classic manifestation of malnutrition. So when a child is born, the child growth is expected as per the WHO reference level. It's a boy, let's say at 1 year, 2 year, the child has to be this taller, has to be certain weight and all. So if the child does not grow to that height, we call this stunting. If the weight is less compared to age, then we call it wasting and so and so. So I'm just showing one example on stunting. Now, this data came from National Health Survey, which is conducted by government from time to time. So what we did is that almost 200,000 children all across the country, their anthropometric measurements are taken. Many other parameters are measured. All we did is simply we assigned exposure because their coordinates are known. So from the day of their birth till the day when the survey was taken, we have how much they have exposed to. And if you look into just the left figure, which shows that how this stunting estimate, which is shown in a Z-score, I will explain to you. So if the value is greater than 0, that means the children is not stunted. If it is lower than 0, the children is stunted. So if you see clearly, when you divide rural and urban children, most of the rural children are stunted. The lower panel, lower line, that is for rural children. Why? Because the major factor of stunting is malnutrition and sanitation, which I have indicated by red color. These are the 2 major factors for stunting. What was not known is that air pollution could be a risk factor. Now what this figure shows you that if you increase the exposure, clearly both the rural and urban children are affected similarly. And then we did some sensitivity studies and all. And again, remember that it's not correlation, because when you try to estimate the impact of one risk factor, so you have to adjust for many other risk factors, which we did. For example, we adjusted for malnutrition, sanitation, solid fuel use, genetic factor, and other things. And the essential message is that yes, air pollution exposure is a major risk factor for child stunting, child wasting, in fact, child and adult anemia. Again, this is another study we did where we have shown that exposure to air pollution increases the anemia risk. And only yesterday we published this paper in Nature Sustainability, where for the first time we show that not for children, air pollution exposure is a major risk factor for anemia in women of reproductive age. And the pathway, the medical colleagues are explaining is something like this. So what they feel is that high air pollution exposure leads to inflammation, which in turn actually increases the secretion of one enzyme called cytokine, and this further stimulates our liver to produce hepcidin, which ultimately inhibits the iron absorption. Now, why it is so important? Because typically you all know that we have an Anemia Mukt Bharat mission where the target is to reduce the anemia prevalence of women below 35%, not just women, both child and women. And let me tell you, India has one of the highest anemia prevalence in the world. As per the latest survey, 67% of Indian children is anemic, and 53 to 55% of women are anemic. And under this mission, government is providing iron supplement, because obviously that was the knowledge that malnutrition is one of the key issues. What we are showing is that air pollution is a major risk factor, and if air pollution exposure does not reduce, then our body's ability to absorb that iron itself also is impacted. And perhaps this is why anemia, despite of all these government efforts, is not really going down, and that's the data is showing. Another study we did with hypertension, and I will just quickly move now, and basically same results. We tried to understand, and this is slightly different. So we looked into the people who live very close to where you have this stubble burning is occurring, within 50-kilometer radius, versus people who live outside. And when you adjust for all other pollution sources and only talk about emission coming from this open biomass burning, you see that it increases the so the people who live actually within close proximity of this open burning are more hypertensive. Exposure and child mortality, we have now robust estimates. You can see obviously that the major factor of child death in India is still malnutrition, 80%. But air pollution is the second largest factor after that. So you can see that in all these things, these are the current knowledge. So when you talk about climate change, first what you have to do is that you have to project what will be the air pollution in future. And this is where actually very less study has been done. In fact, in India, most of the studies focused on how air pollution impacts climate. The other way around, people have not really explored. Because of the climate change, temperature is going to increase, there will be more rainfall, and the boundary layer height will be more because of the higher temperature. Wind pattern will change accordingly. So you need to understand how these meteorological changes will impact air pollution. And for the first time in this work, published a couple of years ago in Nature.com, we showed this is how actually PM level is expected to change with respect to the present day, which is 2010. So you can see that, again, at least in the near future, your pollution level is going to increase. Then only it starts coming down. But not so much if we follow RCP 8.5 scenario. I'm not sure if you know, but perhaps somebody yesterday must have mentioned that the climate change, in science terms, we represent with these RCP scenarios. RCP 8.5 is the most stronger climate change scenario where there will be a 4-degree increase in the temperature by end of the century. Now, it's not just PM. As I said, that demography is also important, right? So you then need to consider what will be the change in demography, and that is actually projected based on this shared socio-economical scenario pathways. And this is very interesting. What it does is that you have these 5 different SSP scenarios: sustainability, middle of the road, fragmented world, and all. Now, there are certain differences. If you want to know more, you can read these documents, but I will explain very quickly. So fragmented world means, there is no consensus between the world to reduce greenhouse gas emissions. Okay, so, and similarly, inequality means some countries are actually, addressing greenhouse gas mitigation, what the governments are committed to and all, and then there are many other scenarios. And you can see that there are demographic projections of population and many other things. Now, if you take all these things, what you can do is that you can sort of project how the health burden due to air pollution will change in future. And again, without going into details, the simple message is that obviously if you follow different scenarios, there will be different changes. But once you have these numbers, then the government can be prepared. Prepared in what sense? That I know that in my district, my state, if I follow certain scenario, this is going to happen in the near future. So once you have such kind of information generated for the policymakers, then you try to build your health infrastructure to counter to it. One positive news I must share with you. You all know that we have the National Clean Air Program to address air pollution, which was launched in 2019. The baseline year was 2017. And what I am showing here is that how many days in a year in any part of our country the air pollution level exceeded the national standard. And what you see here is that there is actually a good progress. In many places, either it is stagnated, that means it has not at least increased, or in many parts, in fact, you see more blue, that means the number of polluted days have gone down. But still, we have to go a long, long way before we actually come to that level. The other important point is that when you talk about cleaning air, it also has an impact on climate. Why? Because these particulate matters, which I am talking about, they cool the climate. So if you remove these particles from our atmosphere system, your climate, the temperature rather will go up. And this is what we try to understand here, that what will happen in 2 different emission scenarios. Baseline means you allow air pollution to move as it is. Mitigation means you reduce your air pollution. So obviously, you see there will be less pollution. But then, as a result, what we found is that there will be 0.3 to half degree increase in temperature. But we then tried to argue that this is not a bad trade-off because you're able to at least save so many lives in these cleaner situations. The other interesting thing is that the impact on heat stress, because if you clean air, your temperature is going to increase. Now, is heat stress also going to increase? The answer is no, not everywhere. You see, what is happening is that in the top panel, without air pollution, with air pollution, more or less, yes, your temperature is going to increase. But not everywhere your increase is more, because your humidity will not change uniformly. So it depends on which climate zone you belong to, and accordingly then you can make a plan for future. Okay, so my final slides, the 5-point agenda that I believe is so important when you talk about climate change and human health. The first is that, as I said, that health sector need to be included with the climate and clean air action plan. Vulnerability assessment, what we are currently doing at national level, it has to be brought down to local level. In my personal opinion, even state or district is not enough. There are distinctive features of Indian cities, rural areas. We now have to come down to at least the city level. Why I'm giving more emphasis on cities? Because more people in future are going to come to cities. Integrated health warning system is very, very important, for which we need interministerial and interstate coordination. And this is, I don't know, I mean, I'm not a political scientist. I don't know how to make that happen. Most importantly for you, academia, to make this happen, we must invest in interdisciplinary research. And that will only happen if we develop skilled manpower through flexible curriculum. Our curriculum, I believe, in India is too rigid. We don't promote, or we don't, promote free thinking. We don't really are training our students, in doing this kind of interdisciplinary work. And finally, 3 I's, very, very important: innovate, incentivize, and implement. So with that, I thank you all for your patience listening. And if there are any more questions, I will be very happy to answer. Thank you.
Thank you, sir, for that stimulating speech. So indeed, I think development of a proper climate resilient infrastructure for any country is an absolute necessity nowadays, keeping in view the constantly changing climate conditions. So definitely we need to know how to design a proper infrastructure so that we can anticipate and finally adapt to this constantly changing climate conditions. So thank you, sir, for that wonderful speech. So now I'd like to have, we can open the session for questions. So if anyone has any question, you can kindly ask, sir.
I actually recently, I'm in physics, but recently I've been worrying about climate change and how it has been impacting health sector, in the sense that we were particularly studying diabetes and the influence of air pollution as well as temperature, rise in temperature on diabetes, or the fraction of diabetic cases around the world. We were looking at around the world, but we wanted to actually look at India more specifically, and more so state-wise. If there could be a distribution that one can find as a function of, let's say, PM 2.5, or for that matter, delta T, which is like the... So I was wondering, when you were talking about heat stress, what is the quantitative parameter that one can use to actually quantify heat stress to relate it to delta T, which is like, when we actually looked at delta T data, it was like for 30 years, there was such fluctuation that it is very difficult, would be very difficult to do any kind of, primary statistical analysis with that. And the average prediction was around 0.6 degrees in 30 years. And probably for a century, if you go to the very extreme climatic change, it would be 4 degrees. But that really, currently in the situation, probably doesn't directly correlate to, it's difficult to find a direct correlation. So I was wondering what would be the, in-between parameter which one can use to actually look at this correlation.
So what I will recommend is that you can use this index which you was talking about, the heat stress, but rather than also looking into the this problem just mere from correlation perspective, you can think of doing cross-sectional studies and on different timestamps. Now, I don't know if you are using secondary diabetes data or not. So that data is available from National Family Health Survey. You can look into.
Okay, so I'll talk.
Yeah, you can talk actually. So those data are available actually, which you can tap into and then do your analysis. Right. Both for pollution as well as. But as far as air pollution is concerned, I will tell you, so far medically, it is proven that only it impacts type 2 diabetes, not all type of diabetes. So you may not get your signal if you are using the total diabetic patients data. It's only diabetes mellitus. We can discuss more.
Yeah, we were looking at type 2, but I think we'll discuss more.
Sure.
Thank you so much.
Is there any more question?
Vector-borne disease. Now, vector control is an important issue. What is the impact of climate change on these mosquito vectors? Because dengue and malaria both are going up in certain areas. Just if you can throw.
Yeah, so what people are looking into, I mean, this is not what I work on, but from my colleagues, what I have heard is they look more into how the transmission window, the ecology itself is changing. But this is one thing where I think more research is required. In fact, not a single study is there that how the pathogens are, whether they are getting adapted to these changes or not, it is not known. So only what is known is how the transmission window is going to change, and based on that, people are trying to do the vulnerability assessment. But that's a really interesting question and worth investigating. Nobody is actually.
Because I was thinking that maybe SPM, if it goes down, more UV will come in. So is there any impact on
Not
mosquito
known,
or-
not known. No
So
study
I was
has been done.
thinking when I was seeing
Yes,
your lecture.
yes.
Thank you.
Yeah, I think we have one more question.
Thank you for the wonderful talk. You mentioned about stunting, which is related with malnutrition. That's understandable. I want to know that how stunting is related to air pollution. What are the factors and how they are affecting the mechanisms and leading to stunting? Is there any study?
So the biological pathway is again complex. One need to do detailed cohorts. Based on epidemiological analysis, two pathways are indicated. One is that so the child, if the child is born with low birth weight, which again is a direct consequence of the air pollution, particularly when the pregnant mother is exposed to high level of air pollution, it increases the chance that the child will born with low birth weight. And if that happens, then it has been seen that that will increase the chance of the child being more stunted. Because if the child is born with low birth weight, your overall immunity will be lower. Other than that, when the child is growing, people are trying to hypothesize that high exposure to air pollution leads to inflammation and the oxidative stress in the body, which will impact. But these are all based on hypothesis, based on the epidemiological analysis that has been carried out. Now, this kind of cohorts are very rare. Today we have two such big cohorts in the country where hopefully in the next couple of years we should be able to generate enough evidence to answer your question more quantitatively. But yes, this is the gray area we have currently. Yeah, so this study, what I was showing is actually a cross-sectional study. So the data is from the entire country. And so what we did is obviously in any cross-sectional setting, you try to adjust for all the confounding factors. So here, the biggest two confounding factors were malnutrition and poor sanitation. In fact, sanitation is another major cause of stunting. And also many other genetic factors, for example, BMI, wealth. And after that, we are showing that yes, air pollution is a major risk factor. So it's all started. So if you look into the study, there are only one or two studies, which is not really enough to fully understand this complex pathway. But these are indicative enough that this is where we need to prioritize and invest more to do research in a more collaborative way.
Thank you, sir, for your excellent presentation. I am Professor Subrato Trivedi from Apex University, Dean of Research and Development. Coming to your slide number 28, you have told that in 2020 and 21, the pollution is less. But whether it is due to the national lockdown induced by COVID, maybe in future it may increase.
No, I mean you are correct. So 2020, yes, definitely helped by lockdown. But if you see also 2019, which was a quite normal year, there are lesser number of bad days. 21, there was no major lockdown. So we'll see into 22 how it pans out. But even based on the data till date, what we have, it looks like in many parts the pollution level is kind of stagnating. If you go before 2017, there is a very sharp increase in the air pollution, which is kind of, stabilizing, and in some parts actually going down. But what we need to do is that still the level is very high, so we now need to bend down the curve, which is sort of stabilizing. So we are nowhere close to meeting our any goal. But I'm showing that, we always keep hearing that the situation is bad, nothing is happening. But at least, we have arrested the rising trend, perhaps.
Yes, and my place, it is in Arunachal Pradesh. It should be cold by this time, but it's extremely hot. So maybe climate change is affecting, and people are telling every year it is become hotter.
Yes.
So we can easily understand that due to climate change, everything, even the biodiversity also changing in the nearby places.
Absolutely, yes.
Yes. Thank you, sir.
Okay, I think we can end the question.
Sir, I have a question. Sir.
Okay, you go on, carry on.
Thank you, sir, for such a lovely talk. I have a question. As we are working with the tribal gut microbiome, we are interested to study the availability of natural resources and their migration along with changes with the gut microbiota. So what national data resources you would like to suggest?
Frankly, I do not know if any national database on that actually exists.
Yeah.
I am not aware of any national database.
Any natural resources you would like to?
I have to think, maybe let me think and I will get back to you.
Thank you, sir.
Yeah, I think, is there any more questions? Okay.
Thank you, Sucharita. Thank you, sir. Sir, I have done my PhD on public health and sanitation in colonial Bengal under Dr. Chitobroto Palit from Jadavpur University. So I have seen a lot of empirical records where we got this kind of impression that what you are trying to, project here, mainly the data and statistics. Sir, the problems which I have seen in the colonial period, my time span was from 1880 to 1947. So some of the problems were, like what I have seen, like that air pollution, definitely the problem of malnutrition was very much there, and which was also one of the main reasons for child mortality that time. So what I want to know, like that time we blamed the colonial government for its colonial indifference, and also the people, especially because they were illiterate and for their lack of literacy. But now, after so many years, after 75 years, we are seeing that the more or less the picture is same if we have knowledge on public health. So, sir, what do you think, like that, what is lacking? Because now we are independent and we are having so many researchers, and it's not like that nowadays we are having. The legacy has started after independence. So that is my one question to you, like that, why we fail to make people aware? So where is the problem? Is there any problem with regard to the funding, or is the problem with regard to the mass education to make people aware? And secondly, in your lecture, you have pointed out that our syllabus is rigid. So I just want to know from which perspective you would like to throw light on this particular aspect, that what kind of rigidity are you trying to highlight? That rigidity in the mindset of ours, which is some kind of, like biased with any kind of political color, or rigidity in that sense, like we are still lagging behind in regard of innovation, science and technology? Thank you, sir.
See, both questions are very interesting. So I will answer the first one. I think there is a great disconnect between science and policy today, even today, and partly the fault lies with all of us. We do science, we keep publishing and we feel happy about it. We have published a good paper. Very few people are trying to actually translate that policy, because when we talk to policymakers, you realize that policymakers don't understand all this scientific jargon. They need time to time policy briefs. Unless you translate that science, what does it mean for policy and also for the common man? Common man does not need, and that is why we are failing to generate any awareness in the society. So there has to be conscious efforts by all of us to take the science that we are doing and interpret it in the simple language. That is the first thing, and we can discuss more in the interest of time. Madam is looking at her watch. The second point is, you were asking, sorry, what was your second question? Yeah. Syllabus rigidity. So what I meant by this is that, the way our, academic, this syllabus and all is structured is that students, cannot take, for example, if somebody is doing biology and wanted to do a problem which requires social science experience. Now, can the student take some courses from social science? Our syllabus does not, or our academic curriculum does not allow. The student will not get credit. In US now, it's so flexible that, an engineering students, we have a colleague who is a mechanical engineer, works in humanities department because he is working in policy. So this is what I meant, that we need to allow students taking courses in a flexible way that will actually help developing the skill required to do interdisciplinary research. We can discuss more.
Yeah, I think owing to time constraints, so we will be ending the question answer session. And thank you once again, sir, for your illuminating talk on this very important topic of utmost importance nowadays. Thank you.
As we arrive at the conclusion of the present session, we would like to reflect on the excellent nuances expressed by Dr. Shagnik De. We are immensely grateful to you, Dr. De, for enriching us with your academic insights.
Now we'd like to invite our next speaker for the session on the dais, Dr. Arup Kumar Mitra. I request Professor Sucharita Roy to please introduce Dr. Mitra.
Yeah, it's my proud privilege to introduce Dr. Arup Kumar Mitra. He's also my sir, so it's a great honor for me to introduce him. Dr. Arup Kumar Mitra is serving as the head of Environmental Studies Department and also in the Department of Microbiology as an associate professor at St. Xavier's College, Autonomous, Kolkata. He has his PhD from University of Calcutta in the year 1995 under Professor R.P. Purokayastho. He has done his postdoctoral diploma from South Bank University, London in ecology and environmental science. He has more than 28 years of teaching experience and is also the founder head of the same department. He has presented more than 55 papers in different national and international seminars. He has written and also edited around 45 books on biology, botany, environmental science, and microbiology. He has published more than 111 papers in different national and international peer-reviewed journals and has many patents under his name. He is also presently serving as the Controller of Examinations in St. Xavier's College, Autonomous, Kolkata. He has been the course coordinator of MOOC courses like Core Microbiology, Food Microbiology, and Botany Plant Groups in the year 2017, 2018, and 2019 respectively. He has students who are presently registered for their PhD degree in the Department of Botany, University of Calcutta, and Department of Microbiology, St. Xavier's College. His research interests include plant pathology, microbiological remediation, edible mushrooms, antimicrobial properties, mangroves, agricultural microbiology, soil microbiology. He has received DBT Star College grant for interdisciplinary research and project for the years 2015 to 2018. WBDST sponsored project on 2017 on plant microbe interaction on arsenic remediation. WBDPT sponsored project on 2018 for a project on mangrove plants and its solution to bacterial, fungal, and cancerous growth. DBT Star College Grant 2019 to 2022, and DBT GOI Development of Biological Control Technology for Invasive Species Polyarthia suberosa humchap in Wildlife Sanctuary for Bethuadhauri, West Bengal, DBT Builder in 2020, and DST GOI projects. He has been the life member, Indian Science Congress Association since 1992, Indian Mycological Society since 1993, National Botanical Society since 1994, Indian Mushroom Society since 1995, Indian Botanical Society since 1996, International Society for Conservation of Nature since 1998, Fellow of the Indian Botanical Society, FBS, since 1998, International Society for Conservation of Nature since 2000, and of the Society of Applied Biotechnology, Mangalore, Karnataka University since 2011. So today, Sir will speak on the sinking island of Ghoramara. Over to you, sir.
Ma'am, before that, Professor, we please request you to felicitate our esteemed speaker.
Thank you very much, Professor Sucharita Roy, for this kind introduction. It is indeed my proud privilege to talk before this august gathering and students. So, respected chairperson, distinguished delegates, and my beloved students, I will be speaking on an issue which actually is an important issue. Let me just speak how this particular problem originated and how we are taking it forward. As a matter of fact, yesterday you listened to Dr. Christina Dragomir from New York University. So she invited me to talk on some impact on climate migration. Global perspective that was organized by the New York University. Then I thought that charity begins at home, so I was trying to look after certain islands in the Sundarbans, because we all know that the climate change, the prevailing impact is resulting in the sinking islands. Islands are sinking, and to a great extent, Ghoramara is not an exception, but it is an important island which is going down. So based on that, I presented the talk over there. And then, before presenting, I really wanted to visit that island. And I went there with some of my scholars, and I really understood that this particular island is gradually sinking, and the hapless people, they have to migrate. The people who can migrate, they will migrate. They will get into other places. I was told that they get into southern India, they get into other parts of West Bengal. But a very important similarity that I was finding, women, they had to stay back. And they have no other alternative, and they have to change their profession, earning a meager amount, and they are staying in that island, and they are facing those wrath of nature. So this particular concept of developing, now you see, we cannot do anything, because at the end of the day, let me tell you, once it is sinking, it will go down. It will go down one day, but can we really favor these people? So there was really some social impact to this particular work, and And that is the reason why, after coming back, I requested my students in EDC and Enactus if we can do something for them. So I just quickly will show you 2-3 slides. Then I will be requesting the students who have made a very beautiful film, and then I will be narrating what we are planning and what we will do so that we can help these people in the coming future, considering this island will survive till 2050. So this is called Project Ghoramara. A very apt name was given by the people of Enactus. They call it Utthan. So you can see this is the island of Ghoramara, and the latitude and longitude is pointed out, and there is the Sagar Island, just north of Sagar Island. So it is a very common question that I was also asking myself. Sagar Island is also facing lot of wrath. Moshuni Island is facing lot of wrath. Then why the problem is with Ghoramara? The problem is, I was just inquiring into the matter, and I found out that actually, because of the diaphragm wall constructed on the Haldia port, the water current has changed. As a result of which, when the water is receding, they are washing away the bank of Ghoramara Island, and that has resulted in the loss of 1 or 2 villages in the vicinity, and the population, which was around 12,000 10 years before, has come down to 4,000, and it will go down further. This is one side of the story. And as a matter of fact, Sagar Island gets lot of publicity, lot of people goes to that particular island. So naturally the proper launch, proper ferry system is there, but there is no good ferry system existing in Ghoramara Island. So when we actually boarded on this boat is not having proper arrangement to sit, and you can see how people were transporting cylinders and sitting there itself and going to that island. And as a matter of fact, the jetty also, which is being used by the Sagar Island ferry, is different, well constructed, and the one which is used by the Ghoramara people is neglected. So that also indicate that where the status of Ghoramara is. And I was feeling that something which is going down, something which is sinking, should we not pay some attention to that? So this was we reached the island, and there is no jetty, as you can see, a very risky proposition to walk into the island, holding a bamboo support and getting into the island. So at this point, I would stop, and I would like to show you the film made by our Enactus and EDC students. Thanks to them. And we really want to take it forward in the globe and try to project and try to get some help out of it so that we can help these people.
Goramara Island, located in the Sundarban Delta, once was home to 40,000 people. In contrast to today, a staggering population of only 2,500 people. The island, fallen prey to climatic change, has experienced various bouts of tropical cyclones and storm surges, some recent ones being the Amphan and the Yas, making the living conditions of the islanders all the more deplorable. Due to the dynamic and complex hydrogeomorphological character of the Hooghly estuary, Goramara is extremely prone to erosion, with the rising groundwater level further degrading the soil, making it unfit for cultivation. Thus, the residents of Goramara, who were once dependent upon the cultivation of rice and betel leaves, have lost their livelihood. Infrequent rainfall due to arid climatic conditions and the scarcity of clean drinking water further degrade the living conditions of the islanders. Neglect by the government has amounted to a severe shortage of daily amenities, with the prevalence of only a couple of grocery and medicinal stores and an extremely capricious electricity supply. On February 25, 2022, Enactus SXC launched Project Uthan with the goal of uplifting the residents of the island by providing them with employment opportunities through spirulina cultivation. Spirulina is a cyanobacteria biomass rich in nutritional value and has immense health benefits. Through a partnership between our college's microbiology department and Orbit Agriculture, an agrotech company, we have access to a culture which would help produce spirulina and then be supplied to pharmaceutical companies to produce spirulina tablets, an anti-inflammatory drug abundant in multiple vitamins and minerals for maintaining a healthy immune system.
Spirulina is an ecologically sound, nutrient-rich dietary supplement with anti-carcinogenic properties, which is capable of reducing cholesterol and blood pressure and can also be used in treating arsenic poisoning, making spirulina the food of the future, and the islanders can become a part of this endeavor by helping cultivate it. At present, the islanders are in dire financial straits, with 44.64% of the families earning a meager income of Rs 1,500 to 2,500 per month. With the help of our corporate sponsors, we would be able to cultivate 50 to 60 kg of spirulina per setup at a cost of Rs 170 to 200 per kg, with the selling price ranging from Rs 1,000 to 1,500 per kg of yield. The return on investment in spirulina farming is quite higher and will bring a change in the islanders' lifestyles, fulfilling UN SDG 11 along with 1, 8, 3, 13 and 12. As Project Uthan gains momentum, our vision is to empower and employ over 60 people and touch the lives of more than 3,000 others by the end of the year 2023. We aim to establish at least 4 such setups that would employ 26 employees. By this year's conclusion, we hope to generate a total revenue of Rs 15,36,000 with Rs 8,88,000 going as wages to our employees. By acting as successful intermediaries between pharmaceutical companies producing spirulina vitamins and the islanders, we won't only be spearheading the socio-economic changes at Goramara Island, but will also contribute in our best efforts to the Indian pharmaceutical industry by producing 1,920 kg of spirulina in the first year of our operation.
Enactus Xavier's College promotes an overall development of all its members to ensure their enthusiastic participation in the activities that we conduct. Thus, we host frequent workshops to disseminate knowledge about the business sector. Our annual flagship event, Enthusia, is another integral part of the Enactus SXC experience, and it significantly aids in improving students' corporate acumen. Additionally, we also host Outreach, an annual interactive session where distinguished personalities educate students about relevant social issues to promote sensitivity among today's youth. Our annual book donation drive, Daksh, conducted in April this year, also produced remarkable results. We organize social drives as part of Enactus Week to broaden our contributions to a larger audience. During the third COVID wave, we had organized a food and vaccination drive to aid with relief efforts, and more recently, a plastic collection drive as part of an ongoing R&D initiative to reduce and recycle plastic waste in the environment. Our team has not only completed 36,500 hours of ideation and learning, but has also reached over 4,80,000 accounts and engaged a total audience of over 2,19,000 people on our social media platforms. With more activities and events on the horizon, Enactus Xavier's College takes an inviolable pledge of seeking possibilities to take action and enable progress.
Goramara, an island 92 kilometers to the south of Kolkata, is quickly disappearing due to erosion and rising sea level. Due to global warming and allied reasons, Goramara had shrunk to less than 5 square miles, about half its size in 1969. This loss of land had caused the displacement of more than 600 families.
The initiative being taken at the Ghoramara Islands by the Entrepreneurship Development Cell and Enactus, St. Xavier's College, Kolkata, in collaboration with the Microbiology Department, aims to make a difference in the fate of the island and its dwellers. EDC aims to visit the island regularly to provide the inhabitants with the necessary resources and to keep a check on the progress of the growth of agriculture and the nourishment of the soil. We are targeting all 5 villages of the Ghoramara Island. We hope that the biofertilizer will help reduce soil erosion, preventing the banjaxing of the island, and that employment by spirulina cultivation will ensure a better standard of living for the residents.
The St. Xavier's Entrepreneurship Development Fund is a non-commercial initiative taken by the Entrepreneurship Development Cell, which connects with such visionary startup founders and assists them in solving problems affecting millions. The EDC Fund serves as a building block among young Xavierians in their entrepreneurial journey and connects them to a pool of mentors, investors, and industry experts, whilst giving them a chance to gain unconditional monetary support, helping these budding entrepreneurs with their startups.
Back to the presentation. Yeah. Thank you very much. So this initiative we are taking from St. Xavier's through our students and active involvement of both EDC and Enactus, you can well understand the objectives are different, but ultimately it is going to help the people out there. One, through the agricultural soil development, and that I will try to explain what amount of research that we have put in with the help of our scholars. And the second is promoting spirulina cultivation, which is relatively easy, and selling it to company, connecting these people with the company. Directly they will buy spirulina and they will earn in the process. So it is a wonderful initiative that has been taken up by Enactus, and at the same time I will try to explain what amount of research that we are putting in so that this particular soil is gaining importance. So when we went there, I actually have divided that area into coastline area, transitional area, and the area hinterland, where the agricultural lands are there, and primarily the crops are the betel leaf, the oil seed, and also paddy. And it was said that after every time, after a year, say for example, the soil loses productivity for 1.5 years almost. So that actually made me think that if we can use the residual microbial flora of that particular area in agricultural productivity, then they will be gaining the fertility back, and we can use some particular salt tolerant germplasm there, so that the production which is lagging for 1.5 years actually will come into place in another 6 months. So this was the initial measurement that we were doing when we were collecting the samples. And these, as I was telling you, the samples were collected from the coast area, from the transitional area, lowland and highland, as it was rightly pointed out. After every such incidence of cyclonic storm, the water level goes up to, say, middle of the island, and for 1.5 months people have to stay back in certain school buildings which are rescue centers basically, and they are provided with food. Mind you, there is no roadway, the only way of transport is that country boat. So this was sampling taking place, and we sampled also from these agricultural sites, and you can see very well the entire paddy field, the crops you can see, but the grains are empty. Nothing is there because it has not grown. Only the plants have grown. The vegetative growth is complete, but the inflorescence was fully empty. And so we were trying to develop the fertilizers. We have developed in the first phase. The second phase work is on. Already some interns are working on that, and we will be providing some good fertilizer for them, which will have salt-tolerant microbes, and that actually will be developed on the basis of internal research, interactive study, so that the soil gains some fertility and agricultural productivity takes up. And we also collected water sample to see what type of microbes are there, because pisciculture is also another option in that island. And in the process, we also saw that there was huge amount of erosion in the other side of the land, where this, you can see this erosion, this sheet erosion gradually is making the island reduced in terms of area. And you can see this entire area, they had the village. That village was completely washed off after the last incident of Yash. So this is definitely a remarkable scenario. You can see the betel leaf. The betel vines are totally empty. They cannot grow it because of the increasing salinity of the soil. The alkalinity has fluctuated and there is no production. This is the status of the land, mostly in that particular area, which we want to transform. And as I was telling, that these people, the people who had to work there, they are working for this sari. It was asked to them that they will only get some 200 rupees for this 7 days work. Can you imagine? They will prepare the sari, but they are only paid 200 rupees, whereas that particular sari will be sold in some shop in Kolkata, maybe at a price of 30,000. So this is the scenario. And there are some schools, and this is the only way of transport, and there are some health camp, mostly private initiatives. We were surveying that island. And so what we are proposing to understand the status of the soil in the coastline, in the transitional area, doing the metagenomic analysis, and at the same time we will try to isolate and characterize the salt-tolerant bacteria, and we will try to see those salt-tolerant organisms, how are they helping the normal microflora, and isolate some good NPK or PGPR activities from those microbes and grow them in the lab and prepare a beautiful consortia which will improve the soil with this biofertilizer. So in one way, it will help these inhabitants to survive against the wrath of nature. Not fully, but to some extent, some sort of solace will be provided. And definitely, I would like to congratulate all my scholars, all the interns working in this project, and all my students who are working. This particular presentation, I have tried to basically include the two things. One is, can we really correlate microbiology or microbiological development with the sociological impact, impacting the people of Ghoramara, improving their economic condition? The work is on, and I am definite that we will succeed in this project. Thank you very much. If there is any question, I am free to answer, but this is an ongoing project. I really want to use this platform to let people know what our students are doing, and I am just acting as a facilitator.
Thank you, sir, for that wonderful presentation. So, indeed, it is indeed a profound and brilliant initiative taken by the Microbiology Department of St. Xavier's College and enactors in order to save the shrinking island of Ghoramara and save the lives of the people. So, thank you, sir. So, if anyone has any question, I'd like to take that. Okay, I think we should,
Thank
yeah.
you very much.
Okay, thank you, sir. Thank you.
We have arrived at the conclusion of the present session. We are profoundly grateful to Dr. Arup Kumar Mitra for enriching us with his expert knowledge and understanding. We also take this opportunity to thank the session chair, Professor Sucharita Roy, for having spared her valuable time to conduct the session with such efficiency and perfection. Knowing is not enough. You must take action. With such words of wisdom, we would now take your leave. We appreciate your patience and look forward to seeing you again after the tea break. The tea break is for 10 minutes. Thank you.